Okay, this is going to be super fast, so if you still have questions at the end, please don't hesitate to ask. So this is a kinematics question, and so we kind of want to start with listing variables. So we know the initial velocity is 0, the acceleration is given as that, there's my time, and I don't know the final velocity or the height. And so if I go through the equations and I'm looking for final velocity, this is the one where I only have one unknown, which is final velocity, and I just substitute in my values. 0 for initial velocity, acceleration is that, time is that, I multiply that together, and that's what I get for my top speed. And then once I know, well, it's not once I know, for the height, I'm going to use this equation. And again, this is still 0, so the whole term is 0. And I just plug in my values, and that's what I get for the height. Okay, so this is a force equation. I can tell because it's talking about forces, and the basic approach for a force equation is to draw a free body diagram. That's always the first thing that you want to do. And we can tell there's 1, 2, 3, 4 forces, so that's 4 forces. Many of you do not know this, but you should because I've said it many times. My weight force is mass times the gravitational field strength. And so mass is 60 kilograms, 10 newtons per kilogram. A couple of you are using 9.8. Do not use 9.8. I may count it wrong on the next one. Use 10. It's what we use in AP. It's what we use in here. So weight, 600 newtons. Normal force, 600 newtons. So those are going to cancel each other out because it's not moving in the vertical direction. And so in the horizontal direction is where I get my net force. I've got 250, which is the forward, minus 60, which is the reverse, and that will give me 190, so 190 newtons. And then for her acceleration, I'm going to use Newton's second law, which is F net is equal to ma. I know my F net is 190 newtons, my mass is 60 kilograms, and so I divide those and I get 3.17. And because my forward force, the direction I'm moving, is bigger than my backward force, that means her speed is increasing. Okay, next thing, I've got an inelastic collision, and I've got a bunch of information. Because I know the combined mass and I also know the final speed, or speed 2, I'm going to start with after the collision because that's what I have information about. And so I know that the momentum is mass times velocity. So the momentum or the mass is the combined mass of the block plus the bullet. And then my speed is 1.1. And so I multiply those together and I get 6.66. Initially, the block is not moving, and so I'm going to have a 0, and then because of conservation of momentum, I know that whatever I end up with is what I have to start with, and it is all in the bullet, so that's 6.66, and the unit for all of these is kilogram meters per second, because that's the unit of mass times velocity. And then in order to find out how fast the bullet was fired, the momentum is mass times velocity. And so I solve for the velocity. So I've got 6.66 divided by 0.05 kilograms. And so that means the initial velocity of the bullet was 133.1 meters per second. And St. Patrick's Day. Okay, the next problem is an energy problem, and I would recommend doing an LOL, although this is kind of the LOL. So initially, I only have GPE. A couple of you put EPE, which I found totally mystifying because that E stands for elastic, and there is no spring here. So initially, I only have the height above the ground. I'm not moving. And then when I get to this lowest point, I have velocity, which I can tell from the whooshies. And then I also have height, which I can tell from this right here. So my final, I've got GPE and KE. The unit of all of these is joules. So I'm going to start here because I know the height, I know the mass is 52 kilograms, and I know the velocity is 13.5 meters per second. And so I just fill in my formulas. MGH is my GPE, 1/2 MV squared is my KE, and so these are the values that I put in for mass, G, height, And then I've got for my kinetic energy, that's the mass, that's velocity. I need to remember to square it. And this is what I get for the total value of the energy. Now, there's no work, no loss, so those are both 0. And therefore, whatever my final is, I have to have as my initial. The reason why I know there's no work is because there's no external force. And so the final is equal to the initial. So initially I had all GPE. So I go to here. Initially I only have GPE. And so that means MGH initial is 7,546. And so I'm just going to solve for H. So I've got H is equal to my total energy divided by my mass and divided by G. And that gives me 14.5 meters, which is right there. Okay. All right, the next one. So impulse, I can think of it either as force times time or a change in momentum. And the thing that's important to remember is that this is the final momentum minus the initial momentum for a single object. And so I know both the final as well as the initial momentum for the football player on the right, and so I'm going to use that one to find the impulse. So my change in momentum, P final, is 120, which is right there, and I'm going to subtract the initial, which is negative 650, so subtracting a negative number means I add them together, so I get 770 kilogram meters per second, which is that. And then I know whatever this football player gained, this one had to lose. So if I start with 800, I subtract 770 and I get 30, so that's my final. It's a positive number, and so that means I'm moving to the right with our convention. And then math problem, I think everyone got that right. Okay, so the next one. I know that I have a 900 kilogram car traveling 12 meters per second to the right, and so I can calculate the momentum. So 900 times 12 is 10,800 kilogram meters per second. The semi-truck is at rest, so semi-truck has 0. The collision lasts 0.8 seconds with an average force of this, so that's how I'm going to find my impulse. So impulse is F times T. 12,800 is my impact force. That's my impact time. And so that gives me my impulse or change in momentum. So that goes right there. And unit Newton seconds or kilogram meters per second. So the car loses this amount of momentum. So I've got 10,800, which is my initial, and I subtract that amount and I get 560. And the truck gains it. So I've got 0, which is initial, plus the change is equal to the final. So that's the final, again, unit kilogram meters per second. And in order to find the final velocity, I'm going to use, I know that velocity is going to be momentum divided by mass. I just solved the equation. So the velocity is 560 divided by 900 gives me 0.622 meters per second for the car. It's a positive number, so the car is traveling to the right. And then for the truck, that's the final momentum divided by its mass is 3,500 kilograms. And so that gives me 2.9 meters per second. Again, positive number, so it's traveling to the right. Okay, so for this one, I had a lot going on. You needed to know that this was a Hooke's law problem, and so this is Hooke's law, F is equal to kx, where x is the change in length. So for case 1 and case 2, I can calculate the change in length. Let's see if I can move this out of the way so you can see it. Yep. Okay, so for the first one, 0.37 minus 0.22 is equal to 0.5, so that was the x. And for the second one, 0.27 minus 0.22 is 0.05, so that was the x there. Now the force, all right, so we've got the x. The force comes from the fact that there's a weight, and remember, mass is not weight, so my mass is 5 kilograms, but my I have to multiply it by G in order to get force, because kilograms are not a unit of force. So 5 kilogram mass times gravitational constant gives me a 50 Newton force. So that's 50 Newton force. And so then I can calculate, I go over to here, so right here. I know my Fs is 50 Newtons. I know my X is 0.15, and that gives me the spring constant. And once I get the spring constant, it's the same spring, so I know it's the same for all three. And Newton meters, Newton meters. Okay, so once I know the spring constant, I can figure out the force for 2. So for 2, I know I've got the spring constant, which is 333, times the displacement, which is 0.05, and that gives me 16.65 newtons. So that goes here. That's the force on this the spring. And then for the last one, I know I've got my force is 80 newtons because this is an 8 kilogram. Same spring, so same spring constant. And so I got F3 divided by K gives me X, and that's 0.24 meters, because again, I'm just solving this one for X. So this is my change in length. I need to add it to my 0.22, which is the original length, in order to get the total length of 3, because that's what it's asking for, so 0.22 plus 0.24. And in order to find the mass for 2, I know that I've got 16.65 newtons, calculated that, divided by gravitational constant gives me 1.66 kilograms. Okay. We have seen this problem. I think this is the 4th time we've seen it. This will be the 4th time I'm going through it. You should make sure you know how to do this problem. It's stunning to me how many people still have no idea how to do it. So it's in free fall. That means the acceleration is the acceleration due to gravity, which is minus 10 meters per second squared. I know the definition of acceleration is that it's the change in velocity each second. So for this one, each second the velocity changes by negative 10 meters per second. And so if I start out at 0, which I do, I'm dropping it. Then after the first second, I'm minus 10 meters per second. Second, I'm minus 20. Third, minus 30. Fourth, minus 40. Fifth, minus 50. If you had this positive, then all of these should be positive. If you did this negative and these were positive, you lost a point. Time is seconds. Displacement is meters. Okay, so displacement is x final minus x initial, and it's given by this equation. And displacement does not depend on the position of the coordinate system. And so those of you who are kind of stuck because I didn't tell you what the reference level is, it doesn't matter. I just use this equation. So my initial velocity is always 0. And so for each blank, I'm going to use this equation. Delta x is 1/2 at squared. Because if you think about it, just when I've dropped it, there's been no displacement. So this number has to be 0. Okay, then for the next one, I'm going to do 1/2 negative 10 times 1 second squared, and I get minus 5. For this one, it's going to be delta x minus 1/2, or equals 1/2 times negative 10 times 2 seconds squared. This one's times 3 seconds squared. Like I said, I've done this multiple times. This is the equation. Look back at your notes. All right. Drummer beats 12 times each second. And so I like sometimes confuse frequency, or when I read a question, I have to think about what is frequency and period. And so I usually write. So this is 12 beats per second. And anytime I have a second on the bottom, I know that's a frequency. So that's the frequency. And so that's frequency is 12 hertz. And then I know the period is the inverse of the frequency. So the period is 1/12, which is 0.083, which is that. And then how many times would the drummer beat the drum in 30 seconds? So 12 beats per second times 30 seconds is 360. Okay, student releases a pendulum as shown. The pendulum swings from left to right in 0.71 seconds. So left to right, they show in the picture, there's only one. I need to come back. That's another 0.71 seconds. And so one cycle is 1.42 seconds. So 1.42 seconds, that is the period. Okay. And then the frequency is the inverse of the period, 1 over 2, 1 over t, so I got 1 over 1.42, and that's 0.7 hertz. So again, cycle, all right. Analyze the free body diagram. That's amazing to me. So I'm going up, but I'm slowing down, which means that acceleration has to be in the opposite direction. And so that means when I'm looking at the normal force of the elevator versus the force of gravity, that the force of gravity has to be bigger so that my net force is going down so that my A can be negative. So what that means is that, again, decreasing, if my net force is 60, so that's the difference between the up and down, I have to subtract it from 600 so that my net acceleration is down. Okay, so 600 minus 60 newtons is 540. Same thing on this one. The speed is decreasing. And so that means if I'm traveling to the right, that means my left arrow has to be bigger. And so I'm going to have 70 minus 50 is 20. I'm not moving in the vertical direction, so that means the weight is equal to the normal force. And so that means the normal force is 750 because that's what the weight is. Okay. Dropping a ball from a building. This is a kinematics problem, and so my basic approach is to write everything down and then think about what equation only has one unknown, and that's the one I'm going to start with. So I know that my displacement is negative 36 because I'm falling. Acceleration is negative 10 because I'm falling under the influence of gravity. I'm dropping, so my initial velocity is 0. And if I want to find the time, this is the equation I'm going to use because that is the only unknown. So I'm going to solve for time. So that goes to 0, multiply both sides by 2. So I get 2 delta y is equal to a t squared. And then divide both sides by a, and I get t squared. And then in order to find t, take the square root. And so that's the formula I get for finding t. And I just plug in my numbers, and I get 2.68 seconds. So that is right here. And then what was the ball speed just before striking the ground? So I want to know the final velocity. And so I'm going to use this equation. Again, it has what I'm looking for, only one unknown. And so V, and it's easier than the other one that I could use. So V is equal to 0 plus AT, A is negative 10, T is 2.6 seconds, so I multiply those together and I get negative 26.8 meters per second. So that's right there. Hi, last one. Marble released at the top of a ramp speeds up steadily, reaching a speed of 90 centimeters per second at the bottom of the ramp. So initial velocity is 0, final velocity is 90. My average, just going to do a standard average, add 0 plus 90, divide by 2, and I get 45. And then spell oscillate.